Good evening all. Last class we have completed up to question number 24. This class we will start question number 25. So 25, what is f of x? F of x is equals to sin x minus cos x. Sin x minus cos x when x is not equal to 0. The function is minus 1 when x is equal to 0. Here this is the value of f of x given. Now we have to check the continuity of the f of x in all cases. So first case I am taking, it is less than 0 case. So case 1 I am considering if x value is less than 0. What will happen if x value is less than 0? If x value is less than 0 means I am going to take in a particular point, let x equal to a. The restriction of a is also less than 0. Now what is the f of x in this case? F of x is equals to sin x minus cos x. This is the value of f of x in the less than 0 case, sin x minus cos x. Now already we have studied that sin x is a continuous function, cos x is continuous function. So we can mention that here. We know that sin x and cos x are continuous. We know that sin x and cos x are continuous. Therefore I can write sin x minus cos x is also continuous. Therefore we can say that f of x is continuous on the interval x is less than 0. What about case 2? Case 2, I am taking the value, that is if x is greater than 0 case. What about the continuity at x is greater than 0 case? So here also I am proving generally, let x equal to a. The restriction of a is greater than 0 here. In this case, what is the value of f of x? That is f of x here also sin x minus cos x. So same thing we can write here. We know that sin x and cos x are continuous function. Therefore sin minus cos also continuous. That also we write in the case 2. So we are writing here, we know that sin x and cos x, we know that sin x and cos x are continuous. Therefore sin x minus cos x is also continuous. So it is also continuous means we can conclude f of x is continuous on the interval x is greater than 0. So case 1 it is continuous x less than 0. Case 2 it is continuous x greater than 0. What about case 3? Case 3 x is equal to 0. So case 3, if x is equal to 0. X equal to 0 means left side of x 0 has different function, right side of 0 have different function. So we have to use LHL and RHL. So LHL of the function at this case, so limit definition of LHL is limit x tends to 0 minus f of x is equals to limit h tends to f of a minus h. What is the value of a here? A is 0, so I am writing here 0 minus h. 0 minus h means f of minus h. So what is our f of x value? F of x value is sin x minus cos x. So f of minus h value will be sin of minus h minus cos of minus h. That you can simplify here itself and apply the limit. Sin of minus theta minus sin theta, I am writing minus sin h. Cos of minus theta plus cos theta, so I am writing minus of cos h. Now applying limit h tends to 0, f of minus h is equals to limit h tends to 0 minus of sin h minus of cos h. Applying limit, what will come? Sin 0, 0 will come. Cos 0, 1 will come. So minus of 1 will come. So LHL will be minus 1. So we will get LHL equal to minus 1. What about the RHL? Write the formula for RHL. So RHL, what is the RHL definition? Limit x tends to 0 plus f of x is equals to limit h tends to 0, f of 0 plus h, that is equal to f of h. This case also f of x is equals to same sin x minus cos x. So now what is the value of f of h? That also same sin h minus cos h. Now apply limit h tends to 0, f of h is equals to limit h tends to 0 sin h minus cos h. Applying 0, sin 0 0, cos 0 1. So minus of 1 will come. So my RHL also is equals to minus 1. So LHL equal to minus 1, RHL equal to minus 1. What about the value of the function f of 0? F of 0 also equals to minus 1. So I can say that limit x tends to 0, limit existing at x equal to 0, that is equals to value of the function. So limit of the function equal to value of the function. Therefore f of x is continuous at x equal to 0. So by case 1, x less than 0 it is continuous. By case 2, x greater than 0 it is continuous. Case 3, x equal to 0 is continuous. So we can conclude that there is no point of discontinuity. So f of x is continuous for all value of x. We should write, therefore f of x is continuous for all values of x. Clear? So far we have proved the continuity. Problem number 26 to 30th. So totally 5 problems, 26 to 30. We have to find the unknown values if the function is continuous at the given particular point. Clear? Question number 26. The function f of x is given that it is continuous at x equal to pi by 2, means we have to find the value of k. So the f of x given here, k into x cos x divided by pi minus 2x. When what is the condition of x here? X is not equal to pi by 2. If at x equal to pi by 2 means we can take the value f of x equal to 3 is given that is continuous at the point x equal to pi by 2. We know that, what we know, if f of x is continuous, if f of x, a given function is continuous at particular point x equal to pi by 2 means, at that point pi by 2 means we can say that LHL must be equals to RHL must be equal to value of the function. So we have to prove either, we have to equate either LHL with f of pi by 2 or RHL with f of pi by 2, because we know that it is continuous means LHL and RHL must exist, both must be coincide. Okay, so now we are taking that LHL alone, or we can take RHL alone. I am taking LHL. So what is the definition of LHL? Limit x tends to pi by 2 minus f of x, that is equals to limit h tends to 0 f of pi by 2 minus h. So now what is the value of f of x in this case? Less than case, that is given that k times cos x divided by pi minus 2x. So what is the value of f of pi by 2 minus x? So I am replacing x in the place, simplifying this. So cos 90 minus theta first quadrant means cos is positive and also cos is changing to sin. So k into sin h will come, divided by multiplying the 2 inside means I will get minus pi, minus into minus plus will come, 2h will come. So these two will get cancelled. Finally I will get k into sin h divided by 2h will come. This is the value of f of pi by 2 minus h, that I can write f of pi by 2 minus h. Now find the value of LHL, that is left hand limit. Limit h tends to 0 f of pi by 2 minus h is equals to limit h tends to 0 k into sin h divided by 2h. Here what is the independent of h will now? So independent of h we have to take outside. So I am taking the k by 2 outside. Limit h tends to 0. Remaining I will get sin h by h. That is value equal to 1. So I will get my LHL equals to k by 2. So what is the value of the function f of pi by 2? F of pi by 2 equal to 3. So we know that LHL equal to RHL equal to f of pi by 2. So first equation implies k by 2 equals to 3. The unknown value k equal to 6. So if k equal to 6 means we can say that this function is continuous at x equal to pi by 2. Clear? See that I have used here LHL alone. Instead of LHL you can use RHL. RHL also, instead of you can use RHL. RHL also we will get same k by 2 only will come, that we can equate with k. So we need only the value of k. So I am finding either LHL or RHL. I found RHL, you can find LHL also, no problem. So question number 27, same, we have to find the value of k. So here the function f of x is given that f of x equal to k into x square. So f of x is given that f of x is equals to k into x square. The condition of x is less than or equal to 2. If it is equal to 3, if x value is greater than 2. It is given that continuous at x equal to 2, we have to find the value of the k. Clear? So now we will use the same LHL and RHL at x equal to 2. X equal to, it is continuous, so I am going to use this continuous at x equal to 2. So we know that f of x is continuous. We know that f of x is continuous at x equal to 2. So we can write LHL is equals to RHL at point x equal to the value of the function f of 2. So I am going to take LHL and equate with RHL. So what is LHL now? LHL equals to, definition of LHL is limit x tends to 2, f of x is equals to limit h tends to 0, f of 2 minus h. So I need the value of f of x and f of 2 minus h. What is the f of x value in less than 2 case? Less than 2 case, f of x value is k into x square. Similarly, what is the value of f of 2 minus h? X in the place, replace 2 minus h. So k into 2 minus h whole square I will get. Now apply the limit. Limit h tends to 0, f of 2 minus h is equals to limit h tends to 0, f of 2 minus h value is 2 minus, that is k into 2 minus h whole square, k into 2 minus h whole square. Applying h equal to 0, 2 square 4 will come, so I will get 4k as my LHL. So LHL is equals to 4k. We can equate RHL or you can equate value of the function. Here the value of the function also equal to LHL, so I am taking RHL here. So what is the RHL definition? Definition of RHL is limit x tends to 2 plus f of x is equals to limit h tends to 0, f of x value is 2 plus h. So in this case, what is the value of f of x? It is greater than 2 case, f of x value is 3. Similarly, f of 2 plus h value also equals to 3. Now applying limit. Limit x h tends to 0, not x. Limit h tends to 0, f of 2 plus h. f of 2 plus h value I have found and kept, that is equal to 3. Apply that here. So I will get 3. So we know that LHL equal to RHL equal to f of 2. By equation 1, we can write that 4k is equals to 3. The value of k equal to 3 by 4. Clear? Similarly, we will find the value of k in the question number 28. So question number 28 also we have to find the value of k. Question number 28, f of x is given that k into x plus 1 if x less than or equal to 5. Question number 28, it is given that f of x is equals to k into x plus 1 if x is less than or equal to 5, 3x minus 5 if x is greater than 5, it is continuous at x equal to 5 given. So we have to, as usual, we have to find the left hand limit and right hand limit at x equal to 5 and we have to equate. So we have tried the we know that f of x is continuous. F of x is continuous at the point x equal to 5. So at the point x equal to 5, LHL is equals to RHL is equals to value of the function. So I am finding LHL and I am finding RHL. So now I am finding LHL value. Definition of LHL is limit x tends to, at 5 I am finding LHL. So 5 minus f of x is equals to limit h tends to 0 f of 5 minus h. So we have to find the value of f of x and f of 5 minus h. So what is the value of f of x here? F of x in less than LHL case. LHL case means less than 5 case, that is k into x plus 1. So what is the value of f of 5 minus h? So k into 5 minus h plus 1. Now apply the limit h tends to 0 f of 5 minus h is equals to limit h tends to 0 f of 5 minus h value is k times 5 minus h plus 1. Apply the limit now h equal to 0 applying means I will get 5k plus 1 is our LHL. So what about RHL in this case? RHL at x equal to 5 is limit x tends to 5 plus, definition of RHL, limit x tends to 5 plus f of x is equals to limit h tends to 0 f of 5 plus h. So what is the value of f of x in this case? RHL case greater than 5 case, f of x equal to 3x minus 5. So what is the value of f of 5 plus h? Replace x in the place 5 plus h. I will get 3 5 plus h minus 5. Now applying limit h tends to 0 f of 5 plus h is equals to limit h tends to 0 f of 5 plus h value is 3 times 5 plus h minus 5. Applying limit h equal to 0, I will get 15 minus 5, that is equal to 10. So minus r, my RHL is equals to 10. So we know that by equation number 1, LHL is equal to RHL equal to value of the function. Value of the function also same as LHL value. So I am equating all LHL and RHL. So my first equation implies, it gives 5k plus 1 is equal to 10. 5k equal to 9. So the value of k is 9 by 5. If the value of k equal to 9 by 5 only, the function is continuous at x equal to 5. Clear? Thank you all. Remaining questions we will discuss in next class. Most probably we will complete this exercise in next class. Next we will start the differentiation, that is differentiability, we will start in next class. Thank you all.